In this video, I am going to cover an iceberg Apache iceberg table creation using Spark. So before I get into the details of how to do that, we talked about in my previous videos, iceberg is an open table format. You can create it on top of any big data file systems. Most importantly, we use Parquet files. Once your iceberg metadata is added on Parquet files, you should be able to read write the data using different query engines. And when we use query engine, it is also important to use catalogs. Catalogs are the ones that saves the metadata of the table definitions and also helps you to build the RBAC system. So it is structured way of managing different files which are residing in Iceberg. We talked about Iceberg features. They follow uh, the core features of Iceberg are they follow ACID transactions, time travel, schema evaluation, and it also needs some table maintenance. So it is important to understand some core features of Iceberg, and primarily it is used for open table format that you can use it to query from different query engines. One of the core features of Iceberg is it being an interoperable table format. In this video, what we are going to cover is create an iceberg table using Spark. So we will go over the quick start guide that Apache Iceberg community provides. We will see what are the components needed and how a table can be created and what is the underlying metadata and data that it is visible. So we have a Docker Compose file. The steps that includes is Docker Compose file. We have creating a table as a second step, writing the data into a table, reading the data from a table, adding a catalog, and if there are next step. So Docker Compose file is having all the images that are needed to set up this whole process. As a prerequisite, we need a Docker or Podman in our system. You can install Docker using brew install if you are using Mac, or you can use download the Docker executable and just install based on the Docker website. Let us quickly go over the Docker Compose file and what are the components in it. So we have a tabular IO Spark iceberg image which contains a local Spark cluster with a configured iceberg catalog. It's a REST catalog. It uses the in-memory from the local computer. To use this, we need Docker CLI. I think you can install with the Docker CLI how to access Docker CLI. And let us go over quickly what are the containers that we are going to spin up and the applications that we need to perform a table creation using Iceberg with Spark. So here in this case, we need a Spark iceberg image from the tabular, and then we need a REST catalog, iceberg REST fixture, iceberg REST catalog container that has iceberg REST catalog. A minio, it is just similar to how you have an S3 on AWS cloud, so you have it in your local machine. And MC is a process that runs to create required directories on the minio. So these are several components that we need part of a table creation using Iceberg. So let us take this Docker Compose file. I'm going to create a folder in my system. So I'm going to have make directory mkdir iceberg demo. So, and then I move to iceberg demo. I don't have any files here. I'm going to bring that folder from the VS Code called iceberg demo. I don't have any files right now. So I'm going to create Docker Compose file, and I'm going to paste that from whatever I got from iceberg documentation. If you take a look at in my iceberg demo folder, I have Docker Compose YAML. We went over all the components that are part of the Docker Compose. So you have a Spark iceberg image and an iceberg REST catalog, a minio S3 like folder structure in local machine, and then MC is a process that uses the minio to create the directories required. Let's go back to the documentation. The next step in this case is to start the Docker containers. So how do you do that? Using Docker Compose up. So I'm going to run this command here. It is currently spinning up the containers that are part of the Docker Compose. If you closely observe, it has created two directories, notebooks and warehouse. Let us also see how the folder structure looks like using minio. So let me grab the corresponding the URL that is needed to look at the data and metadata. For the minio, I'm going to use my web UI on the local host. I'm going to just add this particular one here, high performance object store. I'm logging into minio object store. So from the Docker Compose, I'm using the password and credentials that are provided in the Docker Compose. In this case, it is admin and password. So I'm going to acknowledge, and if you take a look at right now, there is a folder called warehouse and I don't have any data. You have an option to upload, but right now it doesn't have any data. You have an object store created on local system. Now let us go back and check the documentation. So I have my Docker Compose is up and it just brought up applications that are needed. To verify that, I can go back to my terminal and then just add one more terminal and say Docker ps that lists all the containers that are running. In this case, I have Spark iceberg, iceberg REST fixture, and minio. So these are the containers that I need. So I am going to use PySpark in this case. So to do that, how to exec into the PySpark pod. So I'm going to just copy this, go back to my VS Code, go to the terminal, and have this the containers are up. I'm going to use another terminal. I'll just say press plus, and then I'll say docker exec it hyphen it, which is in interactive mode. Spark hyphen iceberg is my container, and PySpark is the application that is part of the container. So I'm connected to Spark here. Let me go back to the website and see what is the next step. So in this case, I'm creating a table using Spark SQL. Create a database if not exists demo.nyc. I'll copy this and run this command. So there is a data frame created, but I'll go and check in minio if this has performed any action. When I refresh this, you still don't see any folders here because an action is not called yet. The next step includes creating a table. If you take a close look at here, from PySpark SQL types, importing all the data types needed, I'm defining a schema with struct type, and I have the column names and corresponding data types: vendor ID, trip ID, trip distance, fare amount, store, and forward flag. So I needed this structure to create a table. In this case, I'm creating a data frame with the schema in it and also writing it into demo.nyc.taxes create, which means I'm creating a schema file under the demo database demo.nyc.taxes. So I'm going to copy this and run this particular file. So what it is doing, let's see. I'll go back to minio and see how the structure is created. I'm going to refresh here. You would see an NYC database access schema and I see a metadata created. If I go back here, NYC taxes is already there. Now it's only a schema created, right? And in the next step, I'm adding the data to it and appending to the table that I've just created, right? So let us see first what is available in metadata. Under metadata, because I'm using an iceberg here, it has the JSON file that stores the metadata, and it also has an Avro file. Let me see if I can expand this here. So I have a metadata file, and if I can download this file and validate the contents of that, right? So let me just open it with VS Code. So open, and the metadata file currently has a format, a table ID, and the location is warehouse NYC taxes, and the last sequence number and last updated timestamp, and the last column ID, and the current schema ID. The schema is type struct, and so it has the required schema fields that we've created. And then let us see what else it has. So all of that schema that we created is available here. So, and it is also pointing to a manifest list file that is present under metadata with this Avro file name snap hyphen. So it has some unique id.avro. Let's go back and check if that file exists. So this is what we were just covering. The metadata is pointing to a snapshot file. This is an Avro file, and it is a list file that is created. Now this only has the metadata information. We don't have the data inserted yet. Let's go back. So this includes just the metadata. Now I see taxes and metadata. Let us go to the next steps of creating a table. So we have the metadata now. Now iceberg catalog support the full range of SQL DDL commands, including the create table, partition by, create table as select, and alter table, drop table. In this case, now let us write the data into the table that we just created. So we have data 1221 with all the details of that NYC taxes. I'm going to create a data frame using the data and also provide the schema I'm reading the schema of that particular taxes here and then writing it again to demo.nyc.taxes dot append. So I'm copying this. I'm going to run that in my PySpark shell. So I have my data added now. Let me go back to the minio and check. So I have taxes. Currently it has data. It is having data and metadata. Earlier I was only having metadata. So this data has all the Parquet files. So I'm not able to expand here, but this data is the data that we just inserted and they're all .parquet files. Now let's see what is changed in metadata. I'll click on the NYC, click on the NYC taxes and data we already see they're all Parquet files. Let's go to the metadata. Now earlier we have seen only metadata and a snapshot file, right? Now I'm seeing there is another metadata.json which is the latest version and there is another snapshot file created, right? What it means, I have, and there is also another avro file, so which means there are three new files created. So part of this iceberg architecture, it will have a metadata that always point to a latest snapshot, and it will also have a list file that will have the list of snapshots which are the the, the metadata list files, and that list file is again going to point to the data files. So in this case, this is my latest metadata. Let's just quickly download it and validate. So in this case, I'm going to open this file with the VS Code and see. I'm going to split this down to different columns and check. If I go all the way here, it is referring to another metadata.json file. So that means it is holding the previous metadata file that we created. At the same time, it is also pointing to, let's see if it is pointing to the snapshot file as well. If you take a look at the current snapshot, it says is this particular ID. And so this file has, you have metadata JSON file, which is a previous metadata file, and also a new snapshot file it is pointing to. Let's go back to the minio and check. There is another snapshot file created at 1:54 my time. So, and if I go and browse this particular file, I'm going to download. This refers to, I'm going to use again the VS Code, or I'll use the text pad for now. So when I use my text, so this particular snapshot file is referring to uh, different the data files that it is actually. So 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 it is saying this particular snapshot file is a manifest file, and the fields that contains this manifest file are the manifest path, the type, and the doc location, right, and the field ID. If you observe carefully, you have avro files. There are two kinds of avro files. One is a the manifest file, and there is a manifest list. The manifest list will have all the manifest files, and the manifest file is going to point to the data files. So on a high level, if you go back here, you have a .json file, which is always the latest JSON that we have to validate when you're creating an iceberg table. and that JSON will point into a manifest list file. The manifest list points to a manifest file. That manifest file has a pointer to the data files. In this case, we have at 154, we have a metadata JSON file created, and a manifest list is also created, and a manifest file is also created, and this will point to the data file that we have available in Parquet format. So this is how the metadata of iceberg looks like. Let's go back to the documentation and see what are the next steps. Now, if I want to read that particular table information, I'm going to use df data frame. I'll go back to VS Code and run this particular one. So it is showing a vendor ID 1221 that we've inserted in the trip ID and the trip distance, the fare amount, and store forward flag. So now we were able to write into a table and read from a table using iceberg from the PySpark environment. So it is currently using a REST catalog. It is a catalog that was spun up, that is used part of this PySpark container. There are other ways you can add a container. Like in this case, we have used iceberg REST catalog, but you can use a Hive Meta Store or AWS Glue or Snowflake's Horizon catalog or Unity catalog from Databricks. So the way to do it is having Spark SQL extensions equals to iceberg Spark extension iceberg. So if you take a look at this particular commands that we have, you can just go back, put this in a file and show like what we have. In this case, we have Spark SQL extensions is there. Spark catalog, Spark underscore catalog is Spark session catalog. It is currently using iceberg REST catalog, and Spark catalog type is Hive, which is a Hadoop catalog, and then it is using catalog local catalog. Local type I said Hadoop, which means Hadoop catalog, but we all of these parameters can be changed to point to a different catalog. For example, Apache Polaris or Unity from Databricks or Horizon from Snowflake or Glue catalog from AWS. It's in our um, hands to update this and whatever the catalog that you want to use. But for this demo, we used an iceberg REST catalog. You would see a table data that you are able to read. So in this case, we just created an iceberg table and used an iceberg REST catalog that holds the table definition. We have also seen the data and metadata folders that are created in minio, which is an S3 like storage object store in local. And then we were able to finally read that iceberg table and display. At the very end, we also went over how to add a catalog part of this whole Spark iceberg exercise. But in this demo, we just close it with using an iceberg REST catalog that we spun up using Docker container.